In the last two videos, we've covered a lot of the fundamental parts of C++, and as promised, we're going to be writing code that we can actually run today. But we're not going to be running that code in this note-taking environment, so let's take a look at the tool we'll use to run our code. This is C++ Shell. This is a neat little web app that lets us write and run C++ code without having to install anything on your local computer, and it will work regardless of what type of computer you have. This text area up here is where we'll be writing our code. You can see we have a couple options that we're going to leave on the default. Make sure we're using the latest version of C++ that this tool supports. We'll leave the warning and optimization level set on default, and keep our standard input set to interactive. And then this is our run button. So we'll write our code, click run, and we'll be able to see the output and interact with our application. You can get to this tool by opening any browser and going to the URL cpp.sh. We'll be using this tool throughout training so that you can follow along with the examples too. With our tool introduced, let's talk about how to write a C++ application. Every program needs a place to start. In programming, we call this the entry point. In all C++ programs, the entry point is a special function called main. Alright, this is what main looks like. Let's look at the 4 parts we learned about in the last video. The identifier for this function, main. No surprise there. The parameter list, which goes between these parentheses, is empty, so we're not taking any input. The return type is an int, and the number that we're returning is called an exit code. This value lets our program signal back to whoever started the program whether or not it ran successfully. By convention, most operating systems and supporting tools define the exit code 0 to mean everything went well, and any non-zero exit codes to be an error code of some kind. Most, if not all, the programs we write together will simply return 0. And if we run this example, we can see that our tool will even tell us exit code 0, normal program termination, as we expected. Alright, now we've got a main function and we've got an application we can actually run. Let's throw in another example function so that we can continue our conversation about scope from the last video. Remember that variables declared in a scope are not accessible outside of that scope. So inside of the main function, we can't directly access variables part A or part B, since they only exist in %A of totals function scope. There is in fact even a third scope in this example, the file scope. Sometimes referred to as the global scope, this scope exists outside of any function or other entity in our code. We don't need any special syntax to begin the file scope, as it starts with the file. There are, however, some limitations to what we can put in the file scope. The only types of expressions allowed in the file scope are declarations. These are the category of expressions we've seen so far that introduce new identifiers into the code. There are many types of declarations we haven't seen yet, but they all boil down to the same purpose, introducing something new. Because our code starts running in the main function, and there is no way to call arbitrary lines of code outside of another function, we can't put any other kinds of expressions in the file scope, nothing that would do anything with any of our data. We've actually been using the file scope ever since we started talking about functions. Function definitions are a type of declaration statement. They introduce the function's name identifier into the program. At the highest level, this example is a file scope with 2 declaration statements in it, each introducing a new function. Now we've got enough structure in our code to run it in an environment like C++ Shell. Unfortunately, we still can't see the results of our code. We'll cover how to do that in the next video.